This is the sixth video on this introduction to robot design in VEX parts. And one thing we were left off talking about chain, and so important thing to remember if you have a drive system and you're using chain and sprockets. In this particular case here, you can see there's the motor, and it's driving these two wheels. So the problem is that this angle right here, so we call this the angle of wrap. You can see that's only looks like it's about maybe 30 degrees. In other words, a part of the chain that's actually in contact with that drive sprocket, out of the total 360, it's only wrapping about 30 degrees. So generally you want to have at least 120 degrees of wrap. So you could fix that problem by doing this. In other words, you just add a second sprocket. So you have two sprockets and you're driving. Now you have plenty of wrap. In this particular case, you can see we have almost 180 degrees of wrap around that drive sprocket. So that's a much better way to do it. You can see that there's a wide variety of wheels that VEX has. These are different types of traction wheels. These wheels right here, you might actually use to, spin them in opposite directions, using them to pick up balls or something like that, depending on what the challenge is that you have to do. So these are smooth, but it's a very sticky rubber. So all of these have a very good coefficient of friction, or in other words, they'll give you good traction. In terms of building pivots, we talked about a little bit about this before. If you use the nylock nuts, so in other words, you put a screw through, maybe these are two steel bars right here, and you have either a Teflon washer or a nylon washer or steel washer in between them, and you tighten up with this nylon, this nylock. It has the nylon inset, but you don't tighten it so that the two bars are pressed tightly against each other, but they're fairly tight together. Somewhat tight together, so now you can use this as a linkage. That's just an easy way to create a linkage with a pivot. So some things to keep in mind when you build your robot for your competition. Generally in these types of small VEX robots around, you want to design it to go about somewhere between 12 to 20 inches per second, depending on the size and weight of the robot. If you design it so it goes faster than that, if you have to climb something, you might not be able to do it. You might not have enough torque. And if you use big wheels, you probably need to have some gear reduction to do that. And we'll talk about that more in the transmission. ARMs normally use compound transmissions. That means instead of just, one small gear and a big gear, you might have to have two sets of gears to get a big enough ratio, gear ratio or speed ratio. And we'll talk more about that later. And then again, remember we talked about how the gears and the motors, you want to support the shafts generally in two places, okay? And if you want to put your bearings close to where the gears, in other words, wherever the load is being applied, if a force is being applied on an axle, you don't want to have a bearing on that axle 5 inches away from where the load is being applied. You want to put the bearing as close to where the load is applied as possible. And some other advice in terms of your design, try not to do too many things well. It's better to do a few things well in general in these types of, you don't know what your robot competition is, but when you strategize to try and come up with a good concept for your robot, you want to try and keep things as simple as possible. And also, if there's a weight limit for your competition, keep that in mind right from the beginning. And then finally, it's always good to try and have something built as quickly as possible so that you can start testing it. And if in this competition there'll be a part where you have to drive it, so you want to practice that. And just 3 suggestions right here: good design, robust manufacturing, and make sure you think carefully about the tactics that you'll be using in whatever the challenge is that you do with your robot. So I'm going to stop here and pick up with another video just to talk a little bit more about VEX parts.